In this video, we're going to talk more about exponential growth and decay. Our target for this video is I can solve a real-life exponential growth and decay problem. So first, let's look at our exponential growth model. Our exponential growth model is the equation y equals c times 1 plus r raised to the t power, where c is the initial amount, r is the growth rate as a decimal, and t is the time period. Now I know before we discussed exponential equations are y equals a times b to the x power. And this b has to be the growth factor, what you multiply by. So this model right here, the exponential growth model, allows you to use the growth rate as a decimal to find out more about the situation. So let's look at an example. So this says you deposit $500 in an account that pays 8% annual interest compounded yearly. What is the balance after 6 years? So we're going to use our exponential growth model, which is y equals c times 1 plus r to the t. So c is the initial amount, so c will be replaced with 500. 1 plus, this is the growth rate, which is 8%, but we have to take 8% and change it to a decimal, which means you move the decimal place, you move the decimal 2 places to the left, so it becomes 0.08. So then you have 500, parenthesis 1 plus 0.08 raised to the t power, and t is the number in years, so that'll be to the 6th power. Now to evaluate this, you'll use your calculator. Alright, so in this, I'm going to type in my 500 and then a parenthesis, 1 plus 0.08, close parenthesis, caret key to raise it to the power for 6 years. And you end up with 793.437. So this equals 793.437. Now remember, we're talking about money. We want to know how much money is in our account after 6 years with our interest. So we're going to round this to the nearest cent. So this 7 tells us to round up, so that 3 is going to become a 4. And so in your bank account after 6 years, you will have $793.44. So that is how you can use your exponential growth model when you're given a growth rate instead of a growth factor. Let's look at a second example. This one says a savings certificate of $1,000 pays 6.5% interest and annual interest compounded yearly. What is the balance of the certificate when it matures in 5 years? So again, we're going to start with the y equals the amount in our account or our savings certificate will be after 5 years. Our initial value of the certificate is $1,000. Our rate is 6.5%. We have to change that to the decimal, so move the decimal to the left 2 places. So it's going to be 0.065. So 1 plus 0.065 raised to the t power, which is in years. So we're at 5 years. We're going to raise it to the 5th power. So again, I take my calculator and I take 1,000, parenthesis 1 plus 0.065, close parenthesis, caret key to the 5th power, and we end up with $1,370 and then 0.086. So that 6 to round to the nearest cent is going to tell us to round the 8 up to 9. So this will be $1,370 and 9 cents will be how much our certificate is worth after 5 years of interest. All right, we also have an exponential decay model, and the equation is very similar. We got y equals c times 1 minus r to the t power. So when it decays, you're just going to subtract that growth rate instead of add it. C is still the initial amount, r is still the growth rate as a decimal, and t is still the time period. So let's look at one example of exponential decay. So this problem says, you bought a used car for $18,000. The value of the car will be less each year due to depreciation. The car depreciates at a rate of 12% per year. Find the value of the car in 8 years. So we're going to use our decay model, which is y equals c times 1 minus r to the t power. So the initial amount of the car is $18,000. The rate is 12%. We have to change that to the decimal. So we're going to move it 2 places to the left. So it'll be 0.12. So minus 0.12 to the t power in years. We're going to do 8 years. So 18,000 times 1 minus 0.12 to the 8th power. I get my calculator. And I type in 18,000 times 1 minus 0.12, close your parenthesis, raised to the 8th power, and you can see that your car will be worth $6,473.42. See, the 1 tells us to keep the cent the same, so we're going to keep it a 2. So after 8 years, your car will only be worth $6,473.42. So hopefully, after these 3 practice problems, you've reached your target that I can solve a real-life exponential growth and decay problem with our exponential growth and decay models. All right, have a good evening.